Hello friends, welcome to follow up. Let's have a look at today's daily challenge problem. Problem 2101. Detonate the maximum bombs. In this video, we're going to explain a solution based on traversal. The problem nature here is that we can transform the problem into a graph problem. But the important thing to be noticed is that here the graph is a directed graph. So this later you can see from example 1. So now let's look at the problem statement. So we are given a list of bombs, and the range of a bomb is defined as the area where its effect can be felt. So this area is in the shape of a circle area, right? So each bomb is represented by three numbers, xi, yi, and ri. So xi, yi is the coordinate of the center, and ri is the radius, right? So we may choose to detonate a single bomb, and when a bomb is detonated, it will detonate all bombs that lie in its range. So these bombs will further detonate the bombs that lie in their ranges. So this is a chain operation, right? So given the list of bombs, return the maximum number of bombs that can be detonated if we are allowed to detonate only one bomb. So this is the problem statement. So let's look at the three examples. So in the second example, the two bombs are very separated. So we can just return output 1. And in the first example, so it gives us some more information. And for example, based on the context here, so bomb 2 is not in the range of bomb 1, right? So if we detonate bomb 1, so the total bombs we can detonate is 1. But bomb 1 is in the range of bomb 2. So if we detonate the second bomb, so the first one is also detonated. So the maximum bombs detonated is 2. So in this, this is also the return for example 1. So similarly, you can interpret example 3. So they change together and each within the range of the other. So we can detonate bomb 0, and then all the others are detonated respectively. So the constraints for the problem are the following. First, the list length is bounded above by 100. So this is a very small number, and this is the bomb representation, right? It's given or represented by three numbers, and these are the ranges assumptions. So with that said, basically we are ready to do the coding and explain the problem logic. And before we move to the coding part, let me first see the big picture. Let's first specify the big picture. So we're going to transform the problem to be a graph problem. And then we are going to write a solution based on, say, DFS. So you can also use breadth-first search due to the small size here. So here in this graph, so the nodes will be the bombs. So I'm going to use index or indices to represent them. For example, we see bomb 0, bomb 1, right? Or node 0, node 1. So this is basically the big picture. It's very standard or natural. So now let's carry out the program. So first, let me get the length of these bombs. And then let's build the graph first. So here we know we have n nodes initially, so we just set them as an empty set for their neighbors for I in range m. So next we are going to build the graph of the edges, so the directed edges. So due to the assumption that the bomb has a length bounded above by 100, so here I do not think too much, just use a double for loop. So for I in range n, and then for j in range I plus 1 to n, right? So for this one, I'm going to get the bomb xi, yi, ri equals bombs I. And for the index j, let's see, xj, yj, rj as bombs j, right? And then we are going to check if I is in the range of j or j in the range of I. So here I'm going to check first. I'm going to check if j is in the range of I. If xj, the distance of the center xj, yj to xi, yi is less than or equal to r I, right? So xj minus xi, so square, plus yj minus yi square. So we compare the radius square. So if this is the case, it means that the j's bomb is in the range of i's bomb. So we're going to make a directed edges, graph I, so add j. So this is one check. Another check is to see if bomb I is in the range of bomb j. So because square is you know, if you change xi minus xj, so it's the same as xj minus xi. So we do not change here or here, but we change this one, less than rj. So this means that bomb I is in the range of bomb j. So we can do graph j and add I. So this way we finished building the graph. So let's see, build the graph, right? So this one maybe you can see is preparation, and this is step 1. And for step 2, so in order to make the code modularized or organized, I'm here going to write a utility function to do DFS. So let me write like this. So I'm going to define DFS. So here we get a source node, let's see, node 0 or node 1, and then we want to see if we detonate this source, how many bombs we can finally detonate. So in other words, we want to locate the connected component initializing from this source node, and then find its size. So here I'm going to use a stack, so I'm going to call this source, and then we use the set to avoid repetition, so let's call it theme. And then let's do the standard while loop, while s. First let's get a node, so s pop, right? And then we are going to check if node not in scene. If this is the case, so we're going to do scene add a node. And then afterwards we're going to check its neighbors for neighbor in graph node, right? Then we are going to put this new neighbors to the stack if they are not in scene. If neighbor not in scene, right? So we are going to do s append neighbor. So this way we pop and we append. We are using this list s as a stack, right? This is the last in first out behavior. So now what we want to do is to return the scene, this set, or we can additionally return the length of this set, but it's just a way of choice. So now we finished this utility function. Thirdly, we're going to prepare the return. Because for this problem, the bomb's length is bounded below by 1, so the result is at least 1. So we're going to initialize a variable called result, initialized to be 1, and then we are going to do comparison during the traversal process. So now let's see. Let's use a big set so that we just avoid repetition. Right. So now let's do this traversal for I in range n. Right. So let's first check if I in visited. So it means that I is already visited, or the corresponding component is already visited. So we are going to continue. And then if this is not the case, so we're going to do DFS to get the corresponding cluster or connected component starting from the source I, right? And then our purpose is to find the maximal bomb we can detonate. So in other words, we want to find the source corresponding to the largest cluster size. So we are going to do max, so the previous state of result and the length of the cluster. And because all the nodes in the cluster are already visited, so we're going to update the overall set using unit operation. So it's cluster. That's why here we return this connected component in the form of a set. So with that done, basically we are ready to do the return, right? So we are going to return the result. So this piece of code forms a solution format for this specific problem. So before we make any comments, let's first do a test. Yeah, it passes one example. I guess this is example 1. So now let's look at the generic case. Yeah, it passes all the generic cases. So here, let me make some extra comments. So it's very important for this problem that we realize the graph here is a directed graph. That's the one thing. Another thing is that in this format of coding or format of solution, we write in a very sketchy way, in the sense that we didn't think too much due to the problem set assumption, because here we have only at most 100 bombs. So therefore you can think of, if we have a very large amount of bombs, what we can do. And also you can think of how to optimize the code and how to solve this problem by other methods. So with that said, that's about it for this video. Thank you.